isolating the variable from its coefficient in the correct order to solve two-step equations. You will also define and identify a complex fraction. Just to review, our golden rule of algebra is whatever we do to one side of an equation, we must do to the other. When we're solving an equation, we isolate the variable, which means we get the variable with a coefficient of 1 alone on one side of the equation. Look below at the equations. Which ones are isolated? In the first example, 6y equals 36, there is a coefficient of 6 beside the y, so therefore this equation is not isolated. In the next equation, you have x over 2 plus 7 equals 19. You can see that there is a constant on the same side of the equation as x, and there's also a coefficient of 2, so therefore this equation is not isolated. In the third example, you have x plus 4 is equal to w. Notice that w is all by itself. It may have a coefficient, but it's 1, which is okay. This means this equation is isolated. In the last example, you have y is equal to 3 minus 1/2. Y is on the left-hand side of the equation all by itself, so therefore this equation is isolated. Let's review one-step equations real quick. Most of the time you can solve one-step equations in your head if you remember what the inverse operation that you need to apply to them is. In problem 2 there you have 4x equals 16. To get x by itself, we notice that there is a 4 that's beside our x. If it's beside it, what do we have to do? Divide it. So that's that coefficient. You would have to divide both sides by 4. 16 divided by 4 is 4. So therefore, x should equal 4. In problem 3, you have 5 plus x equals 17. If we look on the side of the equation with the variable, we see that a 5 is being added to x. That 5 is a constant. To get rid of a positive constant, we would have to subtract it from both sides. So you'd subtract 5, subtract 5. To combine the like term of the 17 that's on the other side of the equation. When we combine like terms, remember you have to use the rule of adding integers, SOB. So because they're opposite signs, we have to subtract. 17 minus 5 is 12. And the bigger sign wins, so therefore x is equal to 12. Process of elimination obviously will tell you what the last answer is, but let's just make sure you understand why it is. Here you have x divided by 3 equals negative 2. On the side of the equation with our variable x, you'll see that you have a coefficient of 3 that's being divided, or it's under our variable. So what did we say to remember how to get rid of a coefficient that's under our variable? You have to move it up and multiply. So times 3 times 3. We use our rules of multiplication of integers here. So x, because our 3's would cancel out, x is equal to negative 2 times 3. Well, you have a negative and a positive. Oh, that doesn't make a very happy person. Should it be a negative 6. So that's why that one's negative 6. So you learned when you were simplifying numeric expressions you had to use the order of operations. That, please excuse my dear Aunt Sally, parentheses, exponents, multiplication, division, addition, and subtraction. And when you did that, you remembered that all multiplication and division was done at the same time, same with addition and subtraction as you work from left to right. To solve an algebraic equation, though, we have to go in the reverse order of operations. So you would first do any addition and subtraction, and then any multiplication and addition. So addition and subtraction, that would be like combining your like terms. Multiplication division would be when you isolate your variable from its coefficient. So when you have an equation that has more than one operation, then you have to apply the inverse operations in the following order. First, you must combine any like terms with addition and subtraction, and then you can isolate the variable from its coefficients with multiplication or division. So let's check to make sure you understand that. Circle the first operation you would undo to solve each one of these equations. Then write the inverse operation you would use to undo the circled operation. So I'm going to get my pen out. Okay. So in the first problem there, it says problem 8 there, it says 3.r, which means 3 times r, plus 16 equals 31. So you must do any addition or subtraction first, so that means we need to get rid of this constant first. That plus 16 is currently what's being added to r, so the inverse of that would be subtraction, or subtract 16. In problem 9, what's the first thing you would have to do there? You have 1/2 times d minus 7 equals 10. Again, look at the side of the equation where the variable lies. You see that 1/2 is being multiplied to d, and 7 is being taken away from d. You must first remove the constant. If that's a negative 7, then that means we would have to add 7 to both sides of the equation. In the final example there, it says 12 is equal to negative 5y plus 2. Look at the side of the equation with the variable. You have a negative 5 that's being multiplied to y, it's that coefficient, and then plus 2. The plus 2 is the constant, so you must always undo your constants first, because that's adding 2. To get rid of it, you would have to subtract 2. So let's look at a problem. What is the solution of 5 is equal to t over 2 minus 3? What is the first operation you will undo? Well, look at the side of the equation with the variable on it. We have a 2 that's under the t, that's a coefficient, minus a 3. That's a constant. Constants always get removed before coefficients. If that's a plus 3 or a minus 3, in order to undo it, we would have to add. The second operation, we would have to isolate the variable from its coefficient. The 2 is under our t, so we would have to move it up and multiply. So our two operations that we would have to apply in order to solve this equation is we would have to add 3 and then multiply two. And I guess this question 11 and 12, let me go back real quick. It says circle the first operation you will undo. They didn't want to know the inverse. Sorry, I should have probably said they wanted to know what operation we were going to undo. Well, we were going to have to undo the subtraction. You would do that by adding. And in this problem number 12, we would need to undo the division, and you would do that by multiplying by 2. So let's solve this equation. I'm going to first write it down. 5 equals t over 2 minus 3. The first thing I would need to do is to combine my like terms. That constant I need to combine with the constant that's over here. So I'm going to add 3 to both sides of my equation, draw my big fat line, and combine. I created a zero pair over here, but on that right hand side of the equation I still have the t over 2, so I'm just going to copy it down. And I'm ready to combine my 5 with my positive 3. That equals 8. Then I need to apply multiplication because I have t over 2. It's under, so I need to move it up and multiply it by 2. Multiply it by 2 on both sides of the equation. The 2 over 2 will cancel out, so I just have t all by itself. And then I just need to simplify the other side of the equation. So 2 times 8 equals 16. My final answer there, 16 is equal to t. Or I can turn it around and put it in standard form, t is equal to 16. Look at problem 2. Let's see if you can apply the steps. Get as far as you can, push pause and work the problem, and then push play when you're ready to check. Okay, let's do this. Now, if you do make a mistake as you're going along, as you're watching the video, then push pause, fix it, and then try to finish the problem and then replay to see if you get the rest of the problem correct. Alright, step 1, let's identify our terms, just so that we know what we need to do first and second. So, I'm going to put a circle around my variable terms. Sorry, that's a pretty big circle. There we go. A square around my constants. So I notice that I do have constants that I need to combine, and I even have a coefficient that's next to my variable. But I know that I need to combine my like terms first. I look on the side of the equation with the variable, and I see that they have the constant of positive 6. In order to combine it with the like term on the other side of the equation, I have to change the sign. Cross those lines, you change the sign. Change it to a negative 6. And then draw my big fat line and combine. The 4k comes down. There's nothing else I can combine it with. The positive 6 and the negative 6 is a 0 pair, so I cancel it out. Is equal to 10 minus 6, or 10 and negative 6. I combine those two terms together, so I subtract, because they're opposite signs. 10 minus 6 is 4. And the bigger sign wins, so it says positive 4. So I've done step 2. Step 3, I need to isolate my variable from its coefficient. I see that it has a coefficient of 4 that's beside my variable. And what do I remember to do? If it's beside it, I have to divide it. So I divide both sides by 4. Notice that I did not change the signs. That's what you do when you combine. I cancel out the 4's. 4 over 4 cancels out. And I just have k on the left-hand side of the equation. On the right-hand side of the equation, I have 4 divided by 4. Well, 4 over 4 always reduces to 1. Any number over itself always reduces to 1. And your final step is to check. Now, just like before, when we're solving one-step equations, to check your answer, you will write down the original equation, but put a set of parentheses wherever you see your variable. Then, take your solution that you get and plug it into that spot. Simplify each side of the equation separately. So we have 4 times 1 plus 6. Now you do have to use the order of operations here because we have an all-numeric expression. So you would have to multiply the 4 times the 1 before you add the 6. 4 times 1 is 4 plus 6 is equal to 10. Does 10 equal 10? Of course it does. So our answer